So wave characteristics. Here already I have given one of the important characteristics, wavelength. It is denoted by lambda. Okay, what is called an wavelength? The distance between two similar points in a wave is called wavelength. In a electromagnetic wave, the distance between any two consecutive crests or thrusts, that is known as wavelength. If you can take wavelength units, centimeters or meters, angstroms, nanometers, micron, millimicrons, or picometers. These all are units for wavelength. Then I have given some conversions. 1 angstrom equals to 10 power minus 8 centimeters. That is nothing but 10 power minus 10 meters. Like that, 1 nanometer equals to 10 power minus 7 centimeters or 10 power minus 9 meters. Okay, their conversions given. Next, one of the important characteristic, frequency. Okay, it is denoted by nu. What is called an frequency? What about that? The number of waves that pass through a given point in a 1 second is called frequency. Okay, per 1 second, particular point, how many waves can be passed through it? That is called frequency. What are the frequency SI units? Second inverse. Otherwise, cycles per second, CPS. Otherwise, hertz. Where 1 CPS equals to 1 hertz, that is nothing but that is equals to 1 second inverse. At the same time, here I have given the relation between wavelength and frequency is what I have given, nu equals to C by lambda. It is one of the important relation between frequency and wavelength, where C is equals to velocity of light. C, that is velocity of light. What is the velocity of light? That is equals to 3 into 10 power 8 meter per second. Otherwise, 3 into 10 power 10 centimeter per second. The C is the constant. That is nothing but velocity of light. 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second. What is called an velocity? The distance traveled by a wave in 1 second is called velocity. So that is completed. So after that, wave number. See this? Wave number. It is denoted by nu bar. Wave number is denoted by nu bar. That is one of the important characteristic of wave, nu bar. What is called wave number? The reciprocal wavelength. The reciprocal wavelength. That is called wave number. The reciprocal reciprocal. Wavelength is called wave number. Otherwise, it is also defined the number of wavelengths per unit length. The number of wavelengths per unit length. That is also called wave number. That is nu bar equals to 1 by lambda. If we can take units, series. So before I have given wavelength units are mainly meter or centimeter. So based on that, what we can say, centimeter inverse or meter inverse, the units of wave number. So here centimeter inverse or meter inverse. Now, the relation between frequency and wave number is, for example, say I have treated it is the equation 1, it is the equation 2. So from 1 and 2 equations, so nu equals to C by lambda. Okay, nu equals to C by lambda. According to this, nu bar equals to 1 by lambda. Therefore, lambda equals to 1 by nu bar. See this? Here, lambda place, I will take 1 by nu bar. Therefore, that is nothing but nu equals to C nu bar. We get series. One more relation from 1 and 2 equations. What we get? One more relations. Nu equals to C nu bar, where nu is nothing but frequency, C is nothing but velocity of light, nu bar is nothing but wave number. These three relations are important with respect to wave properties or characteristics. Okay, these three important. Based on the three relations. Okay, now I will give few problems. What about the relation, wave characteristic relations? Nu equals to C by lambda, nu bar equals to 1 by lambda, nu equals to C nu bar. Right? Now, so all of you write down one problem based on wave characteristics. Based on wave characteristics. Okay, now clear these three relations now. See. So problem number 1. Example 1. So the frequency of given light is frequency. Frequency of given light is 1.0 into 10 power 6 second inverse. What is its wavelength? What is its wavelength? Okay, in centimeters. They are given 4 options in centimeters. That's why I have taken here in centimeters. So how much that? So they are given frequency given. Nu equals to 1.0 into 10 power 6 second inverse given. So we want here lambda. What is wavelength? So according to wave characteristics, so wave properties, what is the relation? Nu equals to C by lambda. We know about this. Nu equals to C by lambda. Okay, what about here? C is nothing but velocity of light. So velocity of light, what about that? C equals to 3 into 10 power 8 meter per second. That is equals to 3 into 10 power 10 centimeter per second. See this. Now here the options 4 given in centimeters. So here I will take the velocity of light value in centimeters. If they are given options 4 in meters, we can take velocity of light in meters. If they are given centimeters, we can take the velocity of light in centimeters. If they are given options in meters, okay, we take the velocity of light in meters. Here centimeters may given. So I will take centimeters. 3 into 10 power 10 centimeter per second. That is nothing but centimeter into second inverse. Upon. What is the frequency here? C. What is the frequency? So C by lambda. They are given. So frequency given, we want the lambda. So what about that? C value, we know that lambda required. Therefore, lambda equals to 3 into 10 power 10 centimeter second inverse upon, what is the new value? 1.0 into 10 power 6 second inverse. This second inverse get cancelled. Now the answer we get in centimeters. How much that? It is nothing but 3 by 1. That is equals to 3 into 10 power 6. We can take up, that is 10 power minus 6, remaining 10 power 4. 3 into 10 power 4 centimeters. That is the correct answer. See this. The wavelength of given light frequency. So that is, we get 3 into 10 power 4 centimeters. Write down all of you. Any doubt here? It is clear. So they are given frequency of light given. What about its wavelength? According to wave characteristics or wave properties. According to wave properties, what we know relation between frequency and wavelength, nu equals to C by lambda, where C equals to velocity of light. They are given nu given, so I have taken lambda equals to C by nu. C by nu. We get 3 into 10 power 4 centimeters. Completed?
Yes, sir, completed.
Yes, sir, completed.
Okay. We'll move second problem. See. So problem number 2. Say if the wavelength of green light is? If the wavelength of green light is, okay, here green light wavelength is given, that is equals to 5000 angstroms given. What about its frequency? What about its frequency? What about its frequency? Okay, see, just what they are given here is the green light wavelength, that is equals to 5000 angstroms, that is given. So what about that light frequency? Okay, do that. Completed. See. So according to wave characteristic, the relation is mu equals to C by lambda. So we know about this relation where mu frequency required. C is nothing but velocity of light. Okay, we know that velocity of light 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second, whatever that. That is the constant value. Very good. That is the constant value. See. So here, one simple thing. So frequency, the units are second inverse. Because of that reason, here the wavelength they are given angstroms. If you can take velocity of light in meters, the wavelength converted into meters. If you can take velocity of light in centimeters, the wavelength angstroms converted into centimeters. That is only. See, if I have taken the velocity of light 3 into 10 power 8 meter per second, that is nothing but meter into second inverse upon lambda. What they are given? Wavelength 5000 angstroms given. 1 angstrom equals to how many meters? Say that.
10 power minus 10.
Very good. Exactly.
10 power minus
10 power minus 10 meters. It is only logic here. If you can take this value centimeters, the angstroms here we are converted into centimeters. Both cases we get the same answer, no problem. Now here meter get cancelled. After that, it is a 3 into 10 power 8 upon 5. It is nothing but 10 power 3. So into 10 power minus 7 remaining second inverse. Okay, now 3 by 5 into. So 10 power minus 7. That is what about that? Plus 7. That is equals to 10 power 15 total. Second inverse. Okay, 3 by 5, 0.6. 0.6 into 10 power 15 second inverse. Am I right? Otherwise, that is nothing but 6 into 10 power 14 second inverse. Here, anyone is the correct, no problem. Write down. Understood or not?
Yes, sir.
Good. Complete karo. So they given wavelength given. What about the light? Green light wavelength they are given. Okay, 5000 angstroms given. Based on that, what about its frequency? So here the relation frequency nu equals to C by lambda.
Completed, sir.
Completed.
Yes, sir.
Good.
Yes, sir. Yes, sir.
Very good. Next, one more problem. See. Okay, this problem is given previous NEET exam. See. Third problem. Okay, see this. Problem number 3. Okay, if the frequency of light, frequency means what they are given, nu, 6 into 10 power 14 hertz. So what is its wavelength? Lambda. What is its wavelength in nanometers? In nanometers. They are given 4 options in nanometers given. Okay, generally the frequency is given 6 into 10 power 14 hertz. What about its wavelength? Options are given 4 options nanometer. Okay, 5 nanometers, 50 nanometers, 500 nanometers, 0.5 nanometers. So what we want here, the lambda value we want in nanometers. Okay, do that all of you. So just here frequency of light given. What about its wavelength? But the wavelength in nanometers required. Nanometers.
Five into 10 power minus 16.
No.
5 into 10 power 2.
Very good. Exactly correct. Very simple. According to wave characteristics, nu equals to C by lambda. Therefore, lambda equals to C by nu. Right? Okay. Now, where lambda equals to C, velocity of light. Okay, 3 into, take the meters or centimeters, whatever that. 3 into 10 power 8 meter per second. That is meter into second inverse. I have taken meters, no problem. If you will take centimeter, that is also correct. So 3 into 10 power 8 meter per second upon 6 into 10 power 14 hertz. Okay, here we know 1 hertz equals to 1 second inverse. So here hertz place, what about take second inverse? Understood that? 1 hertz equals to 1 second inverse according to relation. So both are cancelled. We get the answer now first in meters. Okay, it is nothing but 1 by 2. 1 by 2 into 10 power. 10 power minus 14. Remaining, what about that?
Ten power minus 6.
Minus 6. 8 power minus 6.
10 power minus 6. Am I right? Now, it is nothing but 0.5 into 10 power minus 6. What about that? Meters. 10 power minus 6 meters. Otherwise, that is nothing but 5 into 10 power, what about that? -7 meters. But I want the answer in nanometers. Now this meters converted into nanometers. 1 meter equals to how many nanometers?
10 power 9.
10 power 9.
Very good. 1 meter equals to 10 power 9 nanometers according to relation. Therefore, what we get here? 5 into 10 power -7 into 10 power 9 nanometers. That is nothing but 5 into 10 power 2 nanometers. That is nothing but 500 nanometers. Am I right? It is clear? Any doubt? Any confusion here?
No, sir. No, sir.
Okay. Write down that. Complete करो, do that problem.
सर आपने बोर्ड के एंड में जो लिखा है कुछ दिख नहीं रहा.
What?
बोर्ड के एंड में जो लिखा है ना वो दिख नहीं रहा.
Very good. 1 minute बेटा. अभी दिखते हैं. अभी बराबर है?
यस सर.